So today we're talking about rectangular symmetries and why I think that they are the easiest symmetry to start designing tessellations in. So first, let's take a look at this crease pattern that's on your screen, where I have these groups of 4 closed squares and groups of 4 open squares on the back relative to the closed squares. But is that really the functional unit of this tessellation? So one thing I notice is that there's these lines passing through where everything on one side of the line is also on the opposite side of the line. This is a mirror symmetry line. And so those lines pass through the clusters of 4 in both horizontal and vertical directions for both the clusters of closed squares and also the clusters of open squares. So I'll bring that up a little so you can see more of it. And so if I were to draw all of these lines onto my crease pattern, I would find that they create a bounding box that contains one closed square and one open square. So let's look at some features of this bounding box. The box is a rectangle. It is aligned with the grid directions. So right there we have a property that you can determine that the pattern repeats are going to be aligned with the edge of the paper on a standard grid, aka no rotating grids needed. And a second property is that your positions of high symmetry are all on grid intersections. So you can use a completely standard grid. One caveat with this particular pattern is if we look at our bounding box, we'll see in the horizontal edges of the box, the top and bottom edges, there's one pleat that goes out through it. And on the vertical edges, the left and right edges, there are 2 pleats that go out through this bounding box. So that tells me that for a given number of repeats of the pattern, you're going to have different rates of shrinkage of the paper in those 2 different directions, because in one direction you're shrinking 4 grid spacings for those 2 pleats, and another direction you're shrinking 2 grid spacings for the single pleat. So there's some caveats to keep in mind, but you could easily avoid that particular conundrum of like, well, if I start with a square, I'm going to end up with a rectangle, by making sure that your bounding box has an equal number of pleats out of every edge. So let's look at examples where we're actually making some choices here. I'm going to bring up the custom template. So I'm looking for the square blocks, but not the advanced one, because that's not the one you can get in the free download in the link below. But in here, we've got all of our square twists, and I'm going to kind of arbitrarily pick 4 of them. I'm going to pick a closed on the right handed side, and then I'll connect that with a hybrid on the back. And let's say for number 3, we want a closed on the back, and then let's say we want to open on the front for number 4. And this is a really arbitrary choice of twists. Excuse me. So then I'm going to come and find my CP square, which is right here. One of the things I need to put in a feature request to Inkscape for is to actually order those template names. And so I opened that up. I got rid of the excess line styles that I don't need because I'm copying those line styles from my other template. I'm going to paste those twists in, and I'm going to arrange them so that my choices are in some looped order. Now I'm going to, well, the first thing I'm going to do, actually, is to make sure as I'm dragging things around that I'm matching up with grid lines. And here I need to have these plates all line up. I think I want to rotate, actually no, I don't want to rotate that hybrid, so that the plates will match up, but I will shorten this guy. And I'll shorten this as well, one spacing, and we'll see why in just a second. And I will need to elongate this plate so it reaches the next twist over. And I'm going to grab everything and shift it over so that, so for reference, this upper right corner of the block is the center of my template, of my grid template. And that's where I want to have my mirror lines intersecting. So I'm also going to extend these pleats off of the closed square on the front to match the extension of pleats from the neighboring twists. And I need to do the same for this open square because I can't run the mirror symmetry line. Well, technically I can run it half a grid spacing closer, but I would have a lot of overlap in my pleats, and I don't really want to do that. So I want to get tube pleats. I want to have these places where the nearest parallel pleat, the nearest parallel fold of the same mountain valley assignment is 2 spaces away, just like these 2 valleys are 2 spaces away and these 2 mountains are 2 spaces away. So given that setup, so you saw I chose completely arbitrary twists. I'm going to group that, duplicate, and what I'm going to do is mirror, and it doesn't matter if you do vertical or horizontal first, but I'm going to mirror, in this case, across a vertical mirror symmetry line, and then select all, duplicate again, mirror across a horizontal mirror symmetry line. And now the pleats that come out of the top are the same as the pleats that come out of the bottom. The pleats that come out of the right are the same as the pleats that come out of the left. So I'm going to select all and duplicate and copy that everywhere to create my new pattern. And I don't have to copy it one by one. I can now select all and copy that down and up and wherever else I want it. Now, one thing that will probably come up with this next copy is that depending on exactly how you copy things, you may or may not need the top kind of half copy. So you can leave it ungrouped to more easily get rid of those parts. And one of the things I want to point out here, besides the fact that this particular tessellation has never ever been folded to my knowledge, is that we see stripes. So because I picked 4 twists and arranged them in a loop, we have 2 pleats going out of each direction, which means that for a given number of repeats of the pattern, I'm going to see the same shrinkage in both horizontal and vertical directions. But that's not to say that the space that a vertical repeat takes up is the same as the space that a horizontal repeat takes up. And we can actually, so this is the easiest symmetry to calculate these things as far as shrinkage, because it's always aligned with the grid. So we can take that, I'm going to make that a blue rectangle and expand the line so you can see it. Okay, so we can see that this rectangle is wider than it is tall. It's 2, 4, 6, 8, 9 spaces tall, and 2, 4, 6, 8, 9, 10 spaces wide. That seems a little bit fishy. 2, 4, 6, 8, 10, 11. So how did I know that that was fishy? This center of the bottom edge wasn't pointing at a grid intersection. It couldn't be even. So we've got 9 by 11, and that is going to tell us, like, okay, if I'm going to have this many horizontal repeats, I'm going to have, from a square grid, a slightly different number of vertical repeats. So that's something to take into account. The good news is that these tessellations all have the potential for good borders because they have those mirror lines that pass through that you can just stop there in one direction and let that be a border while you're finishing your repeat on the other. In the case of these squares, you could also stop in the middle in either direction of the block of twists. So that's what we're looking at for designing a new tessellation in this rectangular symmetry. And really designing the tessellation, to me, is synonymous with drawing the crease pattern, especially in these cases where you have the mirror symmetries. You could do it on paper, like physically with paper. I would recommend drawing the first mirror symmetry lines that you want, though. And there's a huge potential of combinations because it's not just pick 2 twists or pick 4 twists, it's pick any number of twists that can be arranged in a rectangle without gaps. And you can design a new tessellation in this square tiling with this rectangular symmetry. And I mean, like you saw, I picked pretty random twists. So closed front, hybrid back, closed back, open front. So if I wanted to make it the same on both sides, I would make this open front into a hybrid front. So there's some flexibility with what exactly you want to do with it. And there's just so much potential going on here. So continuing onwards, there's another tiling that's really amenable to this symmetry that actually has a bit more symmetry. It actually has square symmetry, but using the mirror symmetry lines lets you draw the crease pattern much faster, although it does eliminate half the options. So, not new layer, I'm going to bring up another square crease or square grid template and make that so it's arranged how I want it to be. And this time I'm going to come down to these diagonal squares. So I'm going to choose, and by the way, the diagonal squares could be open as well, but I'm going to grab a closed one, and then I'm going to grab a right triangle. So I picked a square from the right side column, right-handed column. So I'm going to pick my right triangle from the left-handed column, and I'm going to intentionally make a choice that I haven't chosen before. copy those over to my new page. And I'm going to go ahead and center my square. And I want to have this right triangle as close as possible without kind of interfering in the guts of the square twist. So this density, if I were to fold this square twist, this valley fold would be reflected over the mountain and head into the center of the square. So this is putting the corner of the right triangle twist, and this is a open right triangle twist, right at the center of the closed square. But before I do that, let me bring up my diagonals on the grid and verify that everything actually is on proper grid lines. So in order to place it there, I'm going to need to shorten some of these pleats, and I'm going to grab this one and shorten it, and this one and shorten it, and this one and shorten it, 2 spacings. And I'm going to go ahead and shorten the valleys on all of the pleats of my square, because that's going to be a position of 4-fold rotational symmetry. So technically speaking, this isn't strictly rectangular symmetry, because now that I have that triangle in place, and I need to decide at this point exactly how far out I want my mirror symmetry line, so I'm not repeating things that I then want to change. And I'm going to have it be densely spaced, so I can have a triangle tip right at another triangle tip, but I do want to have this extra space so that I get the tube pleat up here. Then I can take this, duplicate, and what I'm going to do is rotate twice, put it on the opposite side, then select the copy and rotate, and they're already centered around the point I want them to be centered on, so when it rotates as a group, it ends up in the right positions. That's a snazzy trick with Inkscape. And then I will think about, okay, and actually, now that I'm looking at it this way, I do need to go back a step and restore those lines, because I actually didn't know that when I copied it out here, I would actually need that line to be longer, because it needs to come all the way out to here. And so I'm going to need to extend those, and I can either go around and extend all 4, or extend it for one of them, delete the rest, and then copy the proper one everywhere. So now I have all of these pleats lining up with a bounding box of the whole thing. So if I select it all, you can see the bounding box, or at least if your video resolution is particularly good, you can see the bounding box. Let's just say in Inkscape, it does show you the bounding box. And I can then group that, duplicate, mirror, drag it over, and noticing things not quite lining up, that's probably a snapping issue, although it could be a template issue, but it's not going to prevent us from doing the full thing. So then I selected both of those, duplicated, and dragged those down, and now the pleats coming off to the left are matching the pleats coming off to the right, likewise for top and bottom. And this is creating a new tessellation. And all we needed to know is, okay, I have some block of twists that I can now mirror everywhere. This is a powerful design tool that is also easier to draw than the other alternatives. And likewise, just like I said with the square twist case, we're going to know in advance that we can use a standard grid on a square. So this is a case where I just need those last two, or that last column, and I can still copy everything or duplicate everything and bring it down, and everything again and bring it back up. I just wouldn't want to make more left-right copies. Then I can get rid of the top. And in these templates, what I do is I select all, group, bring up the mask layer, select that, duplicate, select the pattern layer, and then hold down Shift to also select the mask. And I have a keyboard shortcut. You'll need to go to Object, Clip, Set Clip, and you can see I've set a shortcut of Shift C, and that will restrict your pattern to the boundary of the template. So this 64 divisions in the template is not a folding recommendation. If I was folding this, I would recommend, let's see, so this one is in the center, and I would recommend 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. If you do 48 divisions, that'll get you a ring of the central motif around the a ring of repeats around the central motif, and you'll also have a sizable border. You could also go for 64, and then you'd have another ring of repeats and a small border. So there's options. And these partial twists at the edge that you see in the crease pattern are not necessary to fold if you're trying to leave a border. So that's going to be a new named tessellation. If anyone has name suggestions, go ahead and drop that in the chat. So it's going to be this closed square surrounded by right triangle holes that are then mirrored everywhere. And I'm going to bring up another crease pattern, or sorry, another crease pattern template. And we're going to look at one more option. So we don't actually need to use square twists at all to have a rectangular symmetry. We could do that with only right triangles. So if I were to choose two right triangles and connect them over the diagonal pleat, well, that is going to end up making a square block. So if I've got right triangle here, connected across that diagonal, it makes that square block, and we can then mirror that block everywhere. So let's say that I wanted to have, let's say, a closed on the front and closed on the back. Copy those, and I'm going to have my single diagonals centered so I can place my right triangles appropriately. And I'm going to need to rotate this left-handed one to match up. I'm going to space them that far, so I need to back off the pleats on both of them. And connect them together. So this is one spacing further than corner of one in the closed hole of the other. You could totally do them closer together. And if I select that bounding box, I'm going to see if I can move them to a little bit more centered location, but it turns out, well, if I do it this way, I can. And so what I'm going to do is shorten these two pleats so I get the same behavior on the front and the back. And I can't shorten these vertical pleats because they're needed to give space for the tube pleat that we'll have in the horizontal. So grouping those together, I can duplicate, and once again we'll mirror over a vertical mirror line, select all, duplicate, mirror over a horizontal mirror line, and then I can select all and duplicate to my heart's content. And this is very similar to a tessellation that I call straight-laced, except straight-laced is closer together in the diagonal pleat. So notice what I did here by arranging this grouping of twists so that I was mirroring with an intersection of mirror lines on that central grid intersection. I mandated that the grid that I use, if I was using this as the center, so there are alternative centers. I could center between these same twists on the front side, which is going to be the same result, or I could center in between a loop of 8, but the problem with centering there is that that point is not a point with diagonals that go through it. So if I'm doing that grid, I need to fold all of my horizontals and verticals first and then add the diagonals at the very end. So it feels like you finish your grid, but you're only halfway done. And it's a less precise way of folding a grid. Then I can take my rows and duplicate those as well. And the only reason I'm not selecting multiple rows at a time is because Inkscape tends to play nicer with things if you limit how much you're selecting, basically how much you have unsaved at a given time. But if your computer has a ton of processing power, then probably you can get away with duplicating larger chunks of crease pattern at a time. Still went pretty fast though. So that is what I wanted to show you today. So we're not necessarily drawing the mirror symmetry lines in the crease pattern, although you totally could. We're just using the idea of, I need a chunk of twists that I'm then going to mirror everywhere to set up exactly what I'm going to choose. And then I get those duplicates, so I don't even need the alternate handedness options. So like if I was using, so let's actually go back to that large squares and right triangles example. If I were to take this cluster and then repeat it, but flip it to the other side before I repeated, I would need to grab a whole new set of my twist templates. I'd need the diagonal closed square on the back and the open right triangle twist on the front. Although there is a way to get those from these twists, you make a copy and then convert all the mountains to valleys and all the valleys to mountains. But I think it's easier to grab them from the templates. And then you have to remember that in the new cluster, the triangle is right-handed and the square is left-handed. So there's a lot of simplification when you can just go in and hit that mirror this button. Mirror it that way. There's, yeah, it gets a lot easier when you're able to do that. So we've been looking at first a crease pattern with positions of rotational symmetry only at intersections of mirror symmetry lines. And anytime you have intersections of mirror symmetry lines, the rotational symmetry that you have is half the number of mirror symmetry directions that are intersecting there. So here I have up, down, left, right, intersecting at a point, and it's giving me twofold rotational symmetry. And then we looked at, okay, let's have another cluster. So if the only symmetries in your pattern are due to the mirror lines, you're also going to have these 4 distinct twofold rotationally symmetric positions at the intersections of the mirror lines, which will give you functionally clusters of what's at each corner of the group. And then we looked at a case that actually has more symmetry, but we were able to treat it like something that's going in a mirrored box and not really care that our positions of symmetry were 4-fold in the right-handed square, 4-fold in the left-handed square, and then 2-fold at all of, or I should say identical 2-folds at all of our intersections of mirror symmetry lines. And last but not least, we looked at a case where we can do these boxes around twists that are mirrored without having any square twists involved whatsoever. So that is what's going on with rectangular symmetries, so a box of mirror symmetries with twists. And I will say this only works on square grids because your mirror lines always need to be perpendicular to pleats that cross them. And you never have pleats that are perpendicular to each other in a triangle grid. And yeah, this is the most accessible way to start designing your own origami tessellations. So I invite you to give it a try, download those templates. And if you're interested in more advanced templates and more advanced design techniques, join me this Thursday for advanced twist techniques. And I'll make sure to get that link in the description as soon as we finish recording. So happy folding, happy drawing, everyone. Happy designing. And I will see you for the next stream.